Hello. Welcome to the Unriveted podcast, where we talk about digital transformation, artificial intelligence, and people. Today's podcast is brought to you in part by our book, AI in a Weekend, an Executive's Guide. And with that, John, would you like to introduce our guest?
A fellow author joining us today on the Unriveted podcast, but maybe a little more successful. So I'd like to welcome Chip Huyen. Chip works at the intersection of AI and storytelling. Previously, she was with Snorkel AI and NVIDIA and founded an AI infrastructure startup that was at one point acquired. She taught machine learning systems design at Stanford and is the author of the book Designing Machine Learning Systems, an Amazon bestseller in AI. See, that's something that we can aspire to, Martin. And now her new book, AI Engineering, is coming out shortly and will be available in bookstores probably all over the world. So, Chip, welcome to Unriveted. Thanks for joining Martin and I. We're very excited to have you today.
Hey there. Thank you so much for having me. I'm just really impressed by how your voice immediately switched to very professional podcast voice once the recording button is on. It's really cool.
Thank you. I think it's a good mic. When you have a good microphone, it does most of the work for you. So
I was going to add it's artificial intelligence, but maybe our voice is okay. But Chip, thank you for joining us. Maybe let's get into something really easy. We'll start. Tell us about your motivation about your new book, AI Engineering, Building Applications with Foundation Models.
So I really enjoy writing. But there are things that when you're really upset or stressed and you do it, it makes you feel better. So for me, writing has always been like that. So the motivation for this book, let's see. So it wasn't really like motivation or intention. It was mostly when ChatGPT came out. Like a lot of my friends, they had a little bit of existential crisis. It wasn't that like we were surprised by how good AI was. It was more like the surprise came from like a little bit of improvement in capabilities, enable so many more use cases. It's just like really, really shocking to see how many new applications, new use cases we came up with. And as you said, you like to spend as much time learning about it as possible. So I interviewed so many people, I read so many papers, and I made a lot of notes. And eventually I was like, well, I have a lot of notes. It's a pity. Like maybe I should try to make something useful out of it. So that's how the book came about.
That's awesome. That's awesome. Let's talk about AI 2025. What do you think we should expect from the tech community?
I felt like this kind of prediction question is just like really, really hard. I feel like I don't want to make a fool of myself. So I would love to hear like you, like Martin and John's opinions on what 2025 look like. You promise you're gonna go after me, right? Like if I say my opinion.
A little bit of storytelling here. John and I were at a conference in San Diego not that long ago where we were amongst many of your stellar peers and ourselves talking about the world of data science and artificial intelligence in general and data engineering. And one of the common themes that came up amongst many of the data science people was as follows: we're not really good at predicting the future.
That's why we built AI for it.
Which I found quite humorous in that we're compensated nicely for making judgments and inferences, decisions that could be changing the future. So, we have to be right better than 51% of the time in the world of investment, or we end up losing money. So, big prediction 2025. All these foundational models that are being leveraged better make more than 51% better ROI than they cost, or they're going to be losing money. I think that's pretty clear.
I think I definitely agree with you there. So I think instead of like trying to like predict the future, I can share like what I'm really excited about for 2025. So I'm very excited about a lot of practical use cases. I think it's like in the 2023, 2024, a lot of companies were very hesitant about compliance, who don't understand AI well. But today we understand AI a lot. And we see a lot of investments going into like instead of pre-training into post-training to understand human preference, to understand like how to make AI safer to use. So I do see a lot of use cases, especially around agentic use cases. I'm not sure you saw Elias Uskever talks recently at Neurops about like the end of pre-training. So for a long time, people have observed that like the lower the training loss goes, the better the application performance is. And the question was like, how long can we keep on reducing the training loss? Because there's a concept of like a reducible loss, like we just can't go to like certain threshold. But also like we're running out of data to be able to like put into more pre-training bigger model. So now a lot of investment I can see that can go into post-training, making model more say like safer or like more practical and more investment into use cases. So I'm very excited about that.
Yeah, I agree with that too. I recently read an article that basically was saying kind of the same thing that we saw when data science was the talk of the town, and then machine learning was the talk of the town. And granted, most of these are concepts that are all very intimately related, if not partially overlapping. And saying that businesses, were investing a lot in just adopting something that they could say was data science, or being like, we're building out a machine learning department within our organization, and then we'll figure out how to do something with it. And I think, this, what we've seen with AI is exactly the same, is that a lot of companies are like, oh, now we have to invest, hundreds of millions of dollars in some cases in AI, and then we'll figure out what to do with it after we invest with it. But I think the ship is starting to kind of turn in the other direction, where it's like companies, thankfully, are saying, well, let's try to figure out what the use case is for this beforehand, and then maybe, start small and progress on. So if anything, it hopefully is having a better impact than what we saw a lot of companies throw a lot of money into some of these other technologies and then not have anything to show for it.
Yeah, I think you mentioned about like companies as like looking into use cases. I'm actually a big believer in what I call like, evaluation driven development. So the idea is just like it came from the idea of a test driven development in software engineering. Is that like we need to create tests to test our code. And the same thing is like we need to go to evaluate the applications that we deploy. So it's not a coincidence that some of the most popular applications so far the applications that we have a clear way to evaluate them. So for example, the recommended systems, right? Like we know that maybe better recommended system, we can see that it's strongly correlated to like better purchase through rate or click through rate. For detection system is so that we can measure it by like how many fraudulent transactions we can stop. And also like for example, like coding is so far like one of the most popular, if not the most popular, like generative AI use case. And because with coding, we can actually evaluate the generative code by functional correctness. And does the code compile? Can it like pass through on the unit test? So I do see that like companies when looking more and more ways like to be able to like systematically evaluate the applications. And I think like with a lot of like looking back with a lot of like engineering disciplines, like initially there's always of like demo phase and we're very excited to build demos. And then people started having more systematic approaches to like building it to make it more reliable, more reproducible. And I do think we're gonna see more of that with like applications with variation models.
Absolutely. To move on with our Q&A session, because I know we have a lot of questions and not so much time, but good so far. So going more into the technical aspects of AI, or again, large language models, which are essentially synonymous with what we consider AI today. One of the topics of conversation that's come up is the longevity of the transformer model, which underpins large language models. And obviously there's different flavors, I suppose, of transformer models. But at the end of the day, most foundational models are built off of the transformer architecture. But as we continue to move forward using that architecture, we are definitely seeing limitations, or we're reaching a ceiling, I guess, in the capabilities of LLMs based off of transformer architecture. Now, from what I know, I haven't heard anyone mention, a new approach to building these. So my question is, is there any new deep neural network architecture like a transformer that is going to maybe surpass the capabilities of transformer models to take LLMs or whatever we call them next to the next level? Where does that exist right now, or where are we headed?
So it's a great question. Before I go into the technical of transformer, can I just say something that's like, I don't necessarily think that AI is synonymous with generative like AI or foundation models. I still see that in enterprise use cases, like many still has a traditional classical ML components. So even like in the vast majority of the AI systems that I see people use today, even though they have like foundation model components, they still have like classifier, for example, like a router, scorer. So I do think that's like a very important. And even like for one of the most common pattern for generative AI applications, like the rack system, like retrieval augmented generations, has a retrieval components. It's actually like really built on the foundations of search and recommended systems. So I wouldn't say that like AI is only generative AI, but definitely like generative AI definitely dominates the headlines. So I can see where that comes from. So on the channel, I hope you don't mind me just like jumping in
No,
there.
no, no, no. In fact, I agree with that wholeheartedly. Is that
Yeah.
the systems that should be more prevalent are the ones that are composed of maybe an LLM orchestrator, or in some sense, but a lot of the heavy lifting can still be done by ML models.
Yeah, definitely. So it's a great question on the transformer, and I think like I think transformer like compared to like other technology is incredibly sticky. So like the transformer is not the first architecture for deep learning, and there have been like other architecture came up before it, and like they came and go, but transformer been strong since 2017. So like there are certain disadvantage of the transformer architecture. So one thing is that like it doesn't handle work very well with longer context length, right? Like the auto like it's the attention mechanisms is like it's very memory intensive, and the longer the sequence length, the more expensive it is to run, like both in terms of memory and in terms of like and compute power to run it. And second is that like transformer, so the transformer came at the heel of an architecture called a recurrent, like sec to sec, like sequence to sequence architecture. And compared to sequence to sequence architecture, it is more efficient in the process of like processing the input sequence. So you have like you processing input sequence, and you try to like generate the output sequence, right? So compared to the six to six architecture, transformer can process the input sequence in parallel, making it a lot more efficient. But it's still autoaggressive in generation, as in it has to generate one token after another, and that can be very slow if you want to like produce very long responses. So I do see that like there are a lot of people have been trying to like come up with newer better architecture, but whether it can succeed, I do think it's like no technology lasts forever, so eventually there will be something. I'm just not sure like when. So I do see that there are a few research labs are very active in the space. First of all, Stanford has a lab, as a Chris Ray's lab, like it's working on like space as space model, like something like and Mamba models. It's like very exciting. So I could see like the usual like I was just looking at like a lot of papers along those new architectures, and they usually follow the trajectory. Like first it goes like, wow, this is promising, maybe it can work, and then like, hey, can we make it work for longer sequences, so that we maybe you could test this out with a very small sequence context length, could make it like work longer. Say, okay, now it works. Can we make the models even bigger? Like maybe you start with like maybe 100 million parameter, you start with like 1 billion, 2 billion. But nowadays the model scale is like 100 of billions of like parameters. So can we make it work like that? And then when we reach that, like, okay, it can work with a really big model. Can we make it like more efficient because like we don't have enough compute? And then at some point we need to like make it work with the current hardware. So there's this idea of like so I do think that architecture and hardware are very much intertwined. So like hardware needs to be able to support like current popular architectures, and current like architectures have to be able to run efficiently on current hardware. So like for fun fact, like Transformer, I'm not sure it's fun fact, maybe most will already know, but like Transformer was originally created by Google to run really well on their hardware TPU. And then it became like run when it got popular, and then people like make it work like really well on GPUs. So I do think that's like a hardware like to be like any architecture to be successful need to be able to work really well on hardware. And it's just and the challenge is that it's not just up to the model developer themselves. Like as a researcher, right? Like if I have a really cool architecture, it's not up to me to to just make it work really well on hardware, because it would need collaborations from the hardware industry as well. So it's a back and forth. So I think they're very promising. Maybe it would come from a locations where a company organization that can support both hardware and model research. Uh, that could be a potential locations for where the new architecture might come from. But I also do hope that we will see more and more from the community.
Kind of a related question. Hallucinations are still a pretty significant problem, if not getting worse, because LLMs are becoming more capable of producing text that just people don't want to look into it too deep. But hallucinations are still happening. We're still getting systems that produce false responses. Is there anything that's being done to address hallucinations from the model perspective or the data perspective?
I think there are a lot of being done for hallucinations. I do think it's like whenever I go to conferences, I ask people like who think hallucinations is a big problem. Like it's always more than half people raise their hand. So it's a very very big problems, and it's not a surprise that a lot of people are putting a lot of money and effort and energy into like trying to like work around it or understand it. So I do think it's like one school of research or hallucination is to understand like why hallucination happens, like what makes a model hallucinate. And hallucinations is not always like a bad thing, as I want to put it out there. Like hallucinations like can be a great things for like a lot of creative applications, right? Like they wanted to like come up with like a story, a very unique story that has never happened before, that they need to hallucinate. It's really great for like creating new images or like new designs. So I think it's super cool. So hallucination is usually like an issue when it's like generic responses are factually incorrect, or like factually inconsistent with the context. So for example, like if you ask it some maybe like especially for, so it's a problem for use cases that require very high like factual like correctness or accuracy, like medical use cases, legal use cases, or even like for students to study. So the first approach is to understand like why and how hallucinations happen. And the second is as like understanding how we can like detect it, because it's like the hallucinations happens and it's kind of like silently, like people can just like the response can sound super coherent. And there's some I think there's some paper about like the smarter the AI, like the better it is at like convincing people of like falsified fact. Right? So I think like the smarter people are better at like lying because they can convince like people to believe anything. So it can get really tricky. So it can force like users have to like be really vigilant. And also like the other is like on like issue like how to address it, like so you can like understand like how hallucination happens, how to detect it, measure it, and then like how to address, mitigate it. So I think like there are like a lot of like school of thought, a lot of different techniques. So from the user perspective, I think it's just like maybe you should go from the model developer perspective. So like if people understand this, like people have seen this like as the more time you give the model, the more compute you allocate to the model to think during inference, like the better the results will be. So I think this is very exciting. In terms of like hallucinations are getting worse, I do think this like it's definitely become a bigger issue as AI is being used for more like important use cases, more critical use cases. However, I'm not sure. I do okay. So when I use AI, right? I make note of all the queries that the model has hallucinated in the past. So over the time, I got a collection of like 20 queries. It's like AI, it's like the models like Unit, ChatGPT, Claude have hallucinated in the past. And like every few months, I enter them again. And I realize it's like the model actually hallucinate less, like a lot less on those queries as they used to hallucinate on before. So like some of them, like just because like, they are able to like think more. Like the one on ChatGPT can definitely like hallucinate a lot less, at least of the queries that I use, compared to like just like for like the older generations. And Claude, a lot of time I find is like Claude, like it's pretty good at like abstaining from answering. So first of all, I asked some question, something about something that doesn't exist. It was like, okay, I don't know this. Like this, I can't find anything in my database to answer these questions. So that is also like a good mitigation strategy against hallucinations.
Awesome. We did a whole podcast on hallucinations and had fun with it. But I can argue that, are they really hallucinations, or are they just the machine sharing what it knows, or what it thinks it knows? So, kind of spinning a different direction here, I've used the large language model use case to generate synthetic data to help balance out bias and ethic concerns in data sets. When we have population disparity of male, female, various ethnicities and focuses, and trying to balance the data out. If it's predominantly of male of a certain ethnicity, I want to have a representation that would be more uniform. So I like to use synthetically generated data to help balance it out, so we have something to train against. What are your thoughts of that approach? Am I crazy? I mean, I've only been working with one of those large companies that does CRM and other tools, and they've been using it.
I think this is a great approach. I wonder, like, so when you did that, did you see like the model perform better, like less bias after you use the synthesized data?
Well, that was the hypothesis, and actually that was the outcome. But to be fully transparent, the data was heavily groomed, cleansed, making sure that we're,
As it should.
yeah. Well, we're talking millions and millions and millions of records, and it's hard to visually do that. So you need to automate how you do some of these things in scale. And but yeah, it's super exciting to use it for synthesizing data, and it's been fruitful for me. And I was just curious if you've run across these use cases.
Yeah, I do see that synthetic data is being used more and more. So one use case you mentioned is like to synthesize data to correct for the biases. For example, one use case that I see a lot is that like when you have the data from the past, right? Maybe in the 19th century or 20th century, when it's apparently it's a lot of literature back then was not like up to what we expect to be like particularly correct nowadays. So you can use AI to like correct, like not correct, but like to synthesize more data and to correct the biases from there. And people have been using that pretty successfully. People see a lot. I see a lot with using AI to synthesize like instruction data for like fine tuning, like instruction fine tuning, like human preference data. One paper I really like is like the Llama 3 paper. When they have the Llama 3 paper, so the authors synthesized about like 2.7 million samples to like fine tune the Llama 3 paper. So a lot of them are like code related. So I really like that paper because it touches on an aspect that I think is very important, but people don't talk enough about. It's like, okay, you have some model AI to synthesize data, but then how do you verify that the synthetic data is correct or is good, high quality? So they spend a lot of time on not just data generations, but on data verifications. So like a lot of a lot of the data they generate is actually like coding related. So that allows them to verify the data. So like one of the ways they use is like back translations before coding. Like if you translate the code from one language and to another, will the code still run? Like so okay, so maybe you translate from like Python to C, and then they also retranslate from C back to Python and see like whether it's like it works well, right? And another way is like, okay, you have a documentations. Here's a problem you want the model to write the code for, and then you generate the code, and now you generate back to the documentation to explain that code, and then you compare to generate documentations with the original documentations. So I think a lot of clever way we're using to like evaluate and verify the synthetic data.
Interesting. Let me pick up on this, John, if you don't mind. So you pulled two programming languages out in that last statement that I like to jump on, and it links to how we do development today. For most of many are using for AI is Python. And, when I started this journey, I think we were using C++ and maybe some C low level libraries. And there's a performance delta of running those code bases. So in general, AI is inherently not green, and a significant user of energy. How do you feel we should get around this?
Well, okay, this is an interesting question. I do think it's a very important question, and I do think that we should pay attention to it and we should think about it because we have had some painful lesson from the past, right? Like industrial revolutions, it was like, okay, let's just use fossil fuel to like create energy, to like develop, and then we realize, oh, it's really harmful to the environment. But by then, a lot of damage has been done, and like a lot of the countries and nations that were early in like being able to leverage stuff like fossil fuel to like growth, and other countries like lagging behind, they were like, okay, you already leverage that and growth. Now why are you trying to stop us from like trying to leverage it and like growth like as fast as you know? So I do see that a lot of interesting research around that space. For example, like green data center. So like we're trying to understand more about like so it's like a multiple fast it's a multiple approaches to this because it's not a simple problem. So there can't be like a simple solutions. So definitely one way is just like to make the model like more efficient, right? Like to make the model like really efficient in producing responses. Then maybe like as another direction is to make hardware this is more efficient. Like maybe I think I see a lot of people trying to develop in hardware that maybe run on photon instead of like transistors people are using. Also, like there's also the whole school of like green data centers, like you trying to reharvest the heat generated from data center. So anyway, I'm not really like an expert in that space. So I feel like I'm really out of my depth. I'm struggling here. So somebody save me. But I do think it's a very important question. Yeah.
You're in safe company. And John, thank you for letting me step in there. Maybe we could take it to the funner side of where we're coming from, John.
Yeah, no problem. I mean, and I think too, to circle back, Chip, to what you said earlier, what we were talking is some of the implications of hardware. The marriage between the hardware and the model architecture. I mean, some of those could also have a long-lasting impact on the energy efficiency of how these models work. But again, that's probably it's beyond my knowledge base, definitely. So last question that I wanted to ask was about agentic AI. So we were talking, I think, the question you asked earlier, Martin, was, what's going to happen to AI in 2025? So thinking about agentic AI, what are some of the barriers that you think are going to get in the way, or maybe the things that we can get around to make agentic AI a viable use case for moving forward in say 2025?
I definitely think I'm very excited about agentic use cases. For me, agentic use cases are inevitable. So because agentic pattern is one way to make the model, like to give model a lot more capabilities than the model itself has. So for example, like one very simple example is like instead of training the model to like understand like on the numbers and do math really well, you can just give it access to a calculator. So that is like agentic pattern, right? Like the model knowing when to call the calculator, use a calculator, gets a result back, and then return it to users. I see like many people like see even like using agentic patterns like to turn the model like text only models into the multi-model model. So for example, with just a text model, right? You can really understand text, but if you give it access to say like an image to text model, like so you get the image to text model as a tool. So like now given like an input of both text and image, the model can process text and then it's like call the image to text model to get a caption or description of the image, and then it can process both and then produce a result to the users. So it's a very agentic pattern is a very powerful tool to for people for models, and it's just things that's like it's a no-brainer, right? Because like tools help humans become so much more capable, and tools can also make AI become really capable. So when I see agentic use case, So first, I do think it's like agent use cases are really like everywhere. Like a lot of AI you interact with day to day every agents. Like ChatGPT is an agent because like it can access you like tools. Like it have a such like web search, it has a calculator, it has such like code interpreter. So it has such a lot of tools already. And being able to use tool use is um I'm not sure like say pattern or one of the area of like agentic pattern. So tool use is the other one is planning because now have a lot of tools. Now the model we need to go to like figure out like when to use what. And I want to know that's like when to know that the task has been accomplished, has been done and returned to user, or I want to know when to give up. Like imagine if you give the model like, hey, browse the internet. And if the model just keep on like browsing forever and ever and ever, even though like it's not promising, you don't want that, right? You want the model to know like, okay, this may not be a possible, like this may not be a feasible task, and then just stop there and tells the users like I fail. So there are two areas like tool use and planning. So I do think that's like tool use is perhaps an easier aspect because tool use is like being able to evoke a tool. So let's say that you have an API, which is a tool, and now you need to be able to like extract and call like the right parameters. So the structure output has been very useful in that space, in that area, like to allow the model to like uh, create the right parameters and call the tool, and then incorporate the tool output back into its processing. But the other area is like really, really hard. It's planning. Because like there are a lot of like simple tasks, but then like there are a lot of tasks that like really, really complex. And then planning has so different levels, right? Like you can have different fine grain level of planning. Like you can have like very um I'm not sure, have you ever been in a planning meeting, like quarterly planning or like yearly planning? It's very, very painful. And you can plan for the year, you can plan for the quarter, you can plan for the week, you can plan for day to day. So they're very different granularity of like planning. And things. So the big question we're asking is like, how well can models really, really plan? Because like there's some argument like planning is fundamentally a search problem, right? Like so you look at like all the possible options, like like all the possible paths, and then you try to pick the most promising one, or like try to see, okay, maybe this path is not promising, so we need to like so to do that, a lot of time we need to like do like backtracking, right? And you need to try one and then it doesn't work and go to another. So like if you just let the model do it by itself, like it autocorrect recursive nature and generate one action after another, it's really hard for you to backtrack. Then you might need to provide with tool like a memory tool to know that, oh, it has explored this path before. I'll wait for you to like backtrack and go back. Or like maybe you have like some humans assisted, like maybe domain expertise, like domain experts to tell it like, maybe here's a zero scaffold plan to do this kind of problem, and then lean on that scaffold, use a tool and like break down the problem further. So it's a really, really fascinating problem. I think that blending is extremely, extremely hard.
No, that's fine. And I think it circles back to the energy efficiency conversation too. There's a couple of considerations for agentic AI is, if you do, request, an agentic AI system to perform some particular task, and it chooses a path that ends up not functioning correctly, then, the energy wasted, again, which may be very small, but if you think about it from a, global standpoint, of having to go back and forth and make, API call after API call. And I think that's also not only the energy usage of agentic AI systems that are running autonomously, trying to complete a task and may have to take, several hundreds or thousands of trial and error to figure out how to complete that task or reach that goal, but then the application of that within an organization. And if they let something loose like that, that's making 50,000 calls to, a foundational LLM model, you get your rate limits, you get, all the backlash of overusing the LLM, and then, you look at your monthly bill and you've spent $10 million on an agentic AI system that maybe accomplished, something that saved you $1 million. I don't know. So there's
Yeah.
definitely a few elements in the agentic AI space that also need to be ironed out. But when they are, hopefully, we'll achieve something better than what we have right now.
I think it's like AI can definitely like be very efficient and can definitely waste money more efficiently than humans can. I do think this is one area is especially really hard with like agentic. It's like interesting. It's like labeling the annotations, because like if you ask humans to annotate like here's the best way to achieve this task, you actually find out that a lot of what is efficient for humans is not efficient for AI, right? So for example, like browsing 100 web pages, like for a human, is just like really, really tedious and boring. I don't think a human could choose that path. But like for AI, it's like really easy. You know, just sit down, like open like 100 web page, and like just so like and we see that a lot of people are trying to like come up with an efficient way, like how to annotate. Like here is the way the AI should do it, and you can't just use like human experts to do so.
Excellent. Chip, it's been wonderful having you on Unriveted, and I know we would probably love to have you come back. Thinking about your career and the path you've chosen and how you got here, let's maybe give a takeaway of advice, what you might give yourself if you were to restart your whole career as a younger version of Chip. What advice would you give yourself?
So I think, okay. So one thing that I've learned is that learning is a privilege. So one thing that I'm kind of a bit upset about is the school system somehow makes people think that studying is a chore, like learning is a chore. Like people don't get excited about going there and learn things. But like the more I grow up and the more I have to work, I just realize it's like wow, being able to carve out some time to learn what you want to learn is extremely rare. It's like it's a really privilege. It's a privilege. So I do things like if I have advice for my younger self, is like to appreciate any opportunities that I had for learning and try to create an environment so that I can learn affectionately or effectively. So maybe like surround myself with people that I can learn from, seek opportunities to learn, maybe volunteer for new tasks, even if it's like maybe it doesn't pay quite as well, and maybe it means that increase my working hours, but like just have opportunities to learn and be very, very, very mindful or like intentional about what I want to learn.
That's awesome. With that, we'll call this a wrap, and we'll do a goodbye to our audience, and until we meet again. Goodbye.
Thank you so much for having me. Bye bye.